All right, so we're going to go through an example solving using substitution. We have some steps written out on here. We're just going to go step by step and solve our system. If you remember from the last lesson, a solution is going to be an ordered pair. It's going to be the point of intersection where these two lines cross. It is the point, the ordered pair that satisfies both equations. All right, so step one in substitution is to isolate a variable. It could be an x or it could be a y. It doesn't matter which one, but you want either an x equals and then the rest of the equation, or a y equals and then the rest of the equation. If we take a look at our system, this actually is already done for us. We have this top equation that is y equals. This variable has been isolated. That's what it looks like when a variable is isolated. We could do that ourselves if we needed to, but in this example, we have isolated a variable. What I always do is if y equals 6x plus 7, I'm going to put a box around the 6x plus 7. That leads us to step 2. Step 2 says substitute the quantity equivalent to the isolated variable into the other equation. So essentially, you're going to substitute one equation into the other one. And when we boxed out the 6x plus 7, that is getting substituted into the other equation. Should we substitute it in for the x or in for the y? Because y equals that 6x plus 7, it does need to go in for the y. So then we rewrite our equation. I guess I'll rewrite it down here. Our new equation is going to be 3x minus 8 times y, but y is defined as 6x plus 7, so I'm going to put that in parentheses, 6x plus 7, and then we continue writing our equation, equals 4. And now we have an equation with the same variables, all x's, and this allows us to solve for x. So we're going to take our equation, do any simplifying. We do have this negative 8 we're going to distribute, so I'm going to carry the 3x down. Negative 8 times 6 is a negative 48x. Negative 8 times 7 is a negative 56, equals 4. Before we start solving, we have some like terms we can combine. 3x minus 48x is a negative 45x, minus 56 equals 4. Now to solve, we're going to add 56 to both sides. So we have negative 45x equals 60. Divide both sides by negative 45. And you're probably thinking, oh, it doesn't divide, but that's okay. We can have a fraction answer. 60 over negative 45, both of these will divide by 15. If we take 60 and divide by 15, we get 4. 45 divided by 15 is 3. And then that is going to be a negative fraction. So negative 4/3. So we found half of our solution. Remember, it's an ordered pair. We know that the x is a negative 4/3, and then we just need the y. So step 4, plug the x into one of the equations to solve for the y. But what I like about substitution, well, first, you could plug it in for this y or this y. It doesn't matter which equation you use, but what's going to be the easiest and the least amount of work is if you plug it into the equation that we boxed out. Y is already solved for right here, so y equals whatever 6 times x plus 7 is. So I'm just going to do that work up here. Y equals 6 times, we just figured out that x is a negative 4/3, and then plus 7. 6 times a negative 4/3 is negative 8, and then negative 8 plus 7 is negative 1. So we just substituted the x back into an equation, solve for y. We know that y is a negative 1. So our solution is negative 4/3, comma, negative 1. If we had graphed both of these lines, that would be the point of intersection. All right, so let's try one more example. To do substitution, you need to isolate an x or a y. If it already is isolated for you, even better. This equation, and it won't always be the top equation, this is just coincidence, but we do have the x isolated. We have x equals. So I'm going to put a box around what x equals, y plus 6, and I'm going to take that y plus 6, substitute it into the other equation for the x, because x equals the y plus 6. I'm going to replace the x with a y plus 6, write out the rest of the equation, plus y equals 10. The parentheses, there's nothing to distribute in, so I guess we don't need the parentheses anymore. We can just combine like terms. We have a y plus a y, so 2y plus 6 equals 10, and now we can just solve for y. Subtract 6 from both sides, so 2y is equal to 4. Then divide both sides by 2, so we get y equals 2. Again, our solution is an ordered pair. We just got the y value. To get the x value, just plug it back into our box. X equals y plus 6. So x equals, we just figured out that the y is a 2. So I just plugged in a 2 for the y. And then 2 plus 6 is 8. So 8 is our x, and this is our solution. And remember, we could check the solution. We could plug it into both equations to see if this point is on both of those lines, if it's a solution for both lines. You could graph both of your lines if they were solved, if you wanted to solve for y, just on your graphing calculator real quick to see if it see if the two lines cross at the point 8, 2.